Hi, I'm Kisang and I'd like to explain the structure and the key components of this robot learning repository. This repository is composed of 4 main Twitter notebook files, and I'm going to explain each of the codes focusing on the function. So the first file is teleoperation. In this code, we first get the configuration for the simulation with JSON, generate environment using that dictionary. The JSON file configuration is composed of language instruction, XML file for environment composition, control mode, conditions, and so on. Also, we can check the structure of OMI environment in the environment file inside source directory. As you can see in the file, OMI environment class creates Joko partial class to simulate given situation. We also have several methods to support this simulation, such as reset, step, forward, grab image, render, and get observation. After creating environments, the controller is declared and while sentence is executed to loop and simulate the given environments. Inside the while loop, the environment gets the controller values and apply them to the environment to step. It then grabs the image of the environment and renders. Finally, if the Z key is pressed, the environment is closed and the episode ends. The second file is visualization. This file visualizes the first episode of the given robot dataset, which can be downloaded from Hugging Face with download data.py. First of all, the code gets the dataset and declares the episode sampler, which samples a single episode from the robot dataset. Next, there are some data preparation sequences. And then OMI environment is declared. The while loop is the main loop to execute and visualize the progress of the first episode of the robot dataset. Inside while loop, every 20 Hz, specific data such as queue positions and object positions are put to the environment to update the scene, and the scene is rendered. And the third file is transformation. This file transforms the episode into a dataset used to train networks. First, some parameters are declared. These parameters indicate the result of the data transformation. Then the dataset is created with the name transformed dataset. Next, 2 environments are created. One is OMI environment and second is IK environment. The function iterate episode is declared so that the function iterates through the episode, augment images, and transform actions. Image augmentation is done by changing the color of objects with augment object random color, and action transform is done by util function transform action. Specifically, action transform function transfers given target queue pose into given action type, which can be delta action or end effector pose. After all this, the data is saved according to the observation type. If the observation type is image, then the image is saved, whereas if the observation type is joint pose, the queue poses for the episodes is saved. Using this iterate episode function, the while loop saves all the data sets iterating through given episodes. The last file is training file. The above part is pretty much similar to the code before. And the important part is loading a policy. The class baseline policy is composed of backbone model and vision encoder, which can be trained with the dataset we generated above. After declaring policy, learning rate scheduler and optimizer is defined, and the train loop is executed. The train policy is saved with JIT compilation. After the training sequence, save the PyTorch model and verify if the model is importable. The verify function is executed. So throughout these codes and the repository, we can not only teleoperate the OMI robot arm, but also train neural network model to autonomously execute given action. This is all for the introduction. Thank you.